All right, Algebra 1B. Welcome to part 2 of lesson 7.6, which is about exponential functions. We are going to be talking tonight about graphing these exponential functions. So get your pencils and paper ready. I will have graphing paper available for you when you get to class in order to do your practice problem sets. But for now, we are going to sketch some graphs in our notebook from a table of an exponential function. So we are going to be starting on page 455, actually, it should say 455. So you can turn there with me in your books, please. And we're going to start by making a table where we continue to multiply by 2 over and over and over and over again, starting with the number 3. So our equation here is y equals 3 times 2 over and over and over again, or 3 times 2 to the x power. All right? So if x is 0, let's say, this should be the easiest one for us, because this is going to be 3 times 2 to the 0. Now we know 2 to the 0 power, anything to the 0 power, right, is always 1. So this is 3 times 1, which equals 3. Right? I will scroll down so it's a little easier for me to write this. So 3 is our y value when x is 0. Okay? Let's go up in the positives first, because I think those are going to be a little bit easier for us. When x is 1, this is really 3 times 2 to the 1 power. 2 to the 1 power is just 2. So this is 3 times 2, which equals 6. Right? The next one is going to be 3 times 2 to the second power. And we know 2 to the second power is 4. So 3 times 4, that is 12. One more time, 3 times 2 to the third power. We know that 2 to the third power is 8. So we have 3 times 8. That's what 2 to the third power is. That equals 24. Right? So there's all my positives. Now, if I go in the negative direction, what happens? What changes here? Well, if x is equal to a negative 1, then I have my y value equal to 3 times 2 to the negative 1 power. Now, 2 to the negative 1 power, when we see that negative in the exponent, remember that that flips down and becomes the bottom of a fraction. So this really becomes 3 over 2 to the positive 1. I've just taken my 2 to the negative 1 power, this guy right here, and I flip it to the bottom of a fraction. So I have 3 over 2 to the first power, which we know 2 to the first is just 2, so that's 3 over 2. 3 over 2. Now one more that I want to do so we can see what's going to happen as we continue in the negative direction. If x equals negative 2, right, we have here 3 times 2 to the negative 2 power, and very similar to the one we just did, the negative 1 power. I'm going to say that's the same as 3 over 2 to the positive 2 power. I hope you're tracking with me there using our negative exponent rules of flipping it to the bottom of a fraction. Now we know the bottom of this fraction, 2 to the second power, is really 4. So we have 3 over 4 there. So just to recap, these are our y values for certain x values in this equation. All right? And we can see that we are getting bigger and bigger and bigger as we go to the right. And we are getting smaller and smaller and smaller, now dealing with fractions as we get into negative exponents, right? So our next job then is to graph this function. And the way we're going to graph this function is just by plotting these points, where these points up here are going to be our x values, these down here are going to be our y values. Right? So let's take a look at a graph. This is the graph that I have sketched. It's just two axes that cross with some tick marks on them that I have not labeled yet. I will do that now. I know that this should be positive 1 in my x, 2 in my x, 3 in my x, negative 1 here, negative 2 there, and I don't actually need to go any further than that. That's all that I have in my table. And the highest that I need to go in my table is 24. So let's see, I have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can make a 12th one up there. 12 tick marks. So I'm going to count by twos here. So that's going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24 way up at the top. Okay? Let's start again with our easiest point, right? And that is where x equals 0. Our 0 point in the table just above. So I'll scroll back up so we can see it. There it is right here. When x is 0, our y value was 3. So on my graph, I'm going to go to 0 on my x-axis, which is right here, right at the origin, or where the two axes cross, and I'm going to go up to 3 and plot a point right there. That blue dot is my first point. When x is 0, my y value is 3. Okay? Now, hopefully you can see on the table that's already in your notebook because you wrote it down with me, right, this table up here, so I don't have to keep scrolling back up, that when my x value was 1, my y value became 6. So I'm going to go to x value equals 1 and go up to y value equals 6. 2, 4, 6. There's that point right there. Okay. When my x value was 2, my y value became 12. So I'm going to go over to 2 in my x and go up to 4, 6, 8, 10, 12. Up there, right there is that point. 2 and 12, right? Going over to up 12 and so on. Right? And then when I got to x equals 3, that was when I was at the highest point in my table, which is now the highest point in my graph. So over to 3 and all the way up here to 24, right? So hopefully we can see that this line is getting steeper and steeper. This graph is going up by more and more and more every time. And if I go backwards a little bit in the negative x values, when my x value was negative 1, my y value became 3 over 2, which is 1.5. So that should be just below the 2 right there. Yeah? And then when my x value was a negative 2, my y value was a 3 over 4, which should be even lower, like below a positive 1. So I'm going to go almost down on that x-axis right there. Okay? So those 5 points are what I have in my table. And now all I need to do once I have plotted them is connect them with what your book calls a smooth curve. So just try to make it as smooth as you can, connecting these points, and you can see that it's going to curve up, 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 up like that. Okay? Now, since this graph does not stop at either end of these 5 points, I am going to put arrows on the end to show that it continues like this. Okay? So there in blue is your first example of a graph of an exponential function. Okay? That's what they are going to look like. Smooth curves that continue to get steeper, or they may flip around and get less steep going forward or whatever. But they will look very similar to that. Okay? If you have questions about how I did any of that, please make a note to ask me that in class tomorrow. But I do want you, and there we can check. That's what your book has for you on the top, page 455. And that is page 455, so that we can check our work. Looks good, looks like what we have. And now I want you guys to try these two functions, making a graph of them from a table in your notes. Okay, so again, a table with x and y values, x, y, and I suggest these these x values, -2, -1, 0, 1, 2. That should be enough. Okay? For both of these equations, make those tables where you put these numbers in for x and then get a y value out. And then do the same thing in part B. And once you've made both of those tables, graph those by plotting points and connecting them with a smooth curve. So pause the video, take a look at those two equations, graph both of them, then come back and we will go on. I'm going to keep waiting because I don't know if any of you actually pause this video. Okay, let's graph an exponential model from a word file. Okay, this you will still find on page 455. And it says that computer mapping software like Google Maps allows you to zoom in on an area to view it in more detail. The function f of x, which is just a function where we plug x values in, equals 100 times 0.25 to the x power, models the percent of the original area that shows after zooming in a certain number of times. Right? And they want us to graph this function. Okay? So we can see that this is an exponential equation because we have an x right there in our exponent. Right? When we have a variable in the exponent, we know it's exponential. So we should see an exponential sort of model here in our table. Okay? So let's start by just creating this table. This time we're going to start with x equals 0 because it's impossible for us to zoom in -1 times, right? So we don't need to worry about negative numbers. But we're going to start here with x equals 0. And when x equals 0, this function, f of 0, that's how we write that, f of 0 equals 100 times 0.25 to the 0 power. Right? And we know that 0.25 to the 0 power equals 1. So this is 100 times 1, which is just 100. Slide that over a bit. Okay. Now, when x equals 1, our function f of 1, so we're going to go down here and do f of 1, that's going to equal 100 times 0.25 to the 1 power. And we know that 0.25 to the 1 power is just 0.25. So we need to take 100 times 0.25, and our answer should be 25. Okay? When x equals 2, our function when x equals 2, or f parentheses 2, is going to equal 100 times 0.25 to the second power. If you do 0.25 to the second power on your calculator, you should get 0.125. No, you should not get 0.125. You should get 0.0625. That's what we should get, 0.0625. And if we times that by 100, this is going to equal 6.25. Right? And then finally, when x equals 3, our f of 3 equals 100 times 0.25 to the third power. If you do that on your calculator, please confirm for me that our answer here is 1.56. Right. So we can see now what our coordinate points are, right? We have our x values here. Oops. We have our x values up there. We have our x values right here, and our y values right here. X value, y value, x value, y value, x value, and y value. Okay? Our only job now is to graph. So we're going to take those 4 points, and we're going to plot them on this graph. Right? I'm going to make this go up by 20s, 20, 40, 60, 80, 100. Okay. And I know that x equals 1 there, 2 there, 3 there, and I don't need to go any further than that. Okay? My first point, when x equaled 0, which is right on my y-axis, my point was way up at 100. So that blue dot is x equals 0, y value equals 100. Right? And then my next x value, when x equals 1, my y value, if you remember from our table above, was equal to 25, which is right there. Yes. And then when x equaled 2, our y value was all the way down to 6.25, which is way down there. And when x equaled 3, we were almost down at 0 already. Okay? Now, one thing that we should note is that just because we continually keep multiplying by a number, 0.25 or a 2 or something like that, we can never, ever, ever reach 0. It's impossible for us to reach 0. So please don't ever have your graph go below the x-axis down here. Please never have an exponential graph that does that. This graph should look like this. Come down, connect the dots, curl off, and then just stay right above that x-axis. Okay? And then that one curls up through there and keeps going like that. Okay? There is a sketch of this graph. It's not perfect by any means, but it tells us what we need to know. Okay? If you have questions about how I graphed that, please make a note to ask me in class tomorrow. And then I have one more for you guys to work on, and it's right here. This is, instead of zooming in on a map, we're now zooming out, and so your function is here. I would like you to graph that function that models the percent of the original area that the map shows. So one more time, you're going to create a table with x values, y values, starting at 0 because we cannot zoom out any negative times either. So 0, 1, 2, 3, that should be good enough. Then create a graph. Once you've mastered that problem, you are all set for your practice problem set tomorrow. Like I said, I will have graph paper for you in class tomorrow. That's all I have for you for now. Have a wonderful night.